Screen is visible?
Yes, sir.
Just a minute. Wait. Okay. So in the last class, we have already discussed about the CT, PT, and all the things we have discussed. Next, we will go for that working principle. Based on the working principle, applications, the types. Based on that, the difference between current transformer and second potential transformer we are going to discuss here. The difference between current transformer and potential transformer. It can be treated first one. So see, we have already discussed it with the diagram also we have discussed already. Okay, based on the structure or construction of the current transformer, we are going to connect the current transformer in series or parallel with the line. In these two, current transformer and potential transformer, which one we are going to connect in series? Or both are connected in series, both are parallel in series, parallel with line, and one is connected in parallel, another one is connected in series. So which one is going to connect in series? Which one is going to connect in parallel? Anyone, can you tell me?
Current transformer series.
Which one?
CT.
Current transformer we are going to connect in series. So and potential transformer we are going to connect in parallel, because the current in series we are going to connect here now. Ammeter, while measuring the ammeter, we are going to connect in series the ammeter in line, and the potential difference or potential transformer, potential difference between 2 points, we have to take that one. So from one point to one end to another end we have to connect. For that reason, it is going to connect in parallel. So the first difference of the CT and PT is based on their connection only. Based on their connection only. So it can be treated as a series transformer under virtual short circuit conditions over there. We are going to do the short circuits for that one, and for the potential transformer we are going to do the open circuits over there. So it can be treated as series transformer and it can be treated as parallel transformer. The potential transformer is treated as parallel. We are going to do the connection in parallel over there. Shubham Mali. Okay, next, the secondary must be always shorted over there. The secondary one, we are going to short that one here. I think the diagram also you have to take. Just a minute, I will take the diagram also. Better option for you peoples for understanding. Can take the diagram. So much things where it is. Okay, this one. With the diagram, you will understand more. For that reason, I will take the diagram. The diagrams are visible now?
Yes, sir.
Okay. See here. See this one, the secondary of the second difference is secondary must be always shorted over there here. See here, it is shorted here. The switch for connecting the ammeter for the short circuit. If the switch is closed, then secondary will be short circuit. If under non-measurement condition, we can short circuit that one, then it is closed, the current will flow in a closed conducting path over there. But What about the potential transformer? It is connected to the ground. If there is no voltmeter, I will remove the voltmeter, means what will happen here? It will act as an open circuit here. The secondary is nearly under open circuit condition here, because we are going to measure the potential difference between one term to the another terminal here. Now that is grounded here now, or earthed we are going to call that. Okay, first one, it can be treated as series transformer here. So here the transmission line is there. In series with the transmission line, we have connected a current transformer. We have connected in series with the line, we have connected the transformer, current transformer. But here, see here, the transmission line, we have not disturbed anything. We have tapped the supply here now. So parallelly, we are taking some other supply. Parallelly, it is connected here now. So that's why the potential transformers are connected in parallel, and series transformers, current transformers are connected in series, and the secondary must be always short circuited here now, shorted here now, and it will be opened here now. Why it is going to open? You just tell that one here. The one more example I can give here now. The emitter has very less resistance here. It is very less resistance it has. So less resistance means maximum current will flow here. Yes. If the resistance is low, then current will flow maximum. Yes or
Yes,
no?
sir.
Oh, and under the short circuit condition, there is no resistance at all. Then only the current will flow. Under the open circuit, the current will flow. No. So like that, the voltmeter has very large resistance here now. This voltmeter has very large resistance. For that reason, it is going to oppose the flow of current here. No. So if it is opposing, means no current will flow, then it acts as an open circuit over there. So for that reason, secondary is nearly under open circuit conditions, we are going to tell them. So that is the second difference. A small voltage exists across its terminal as connected in series here. It is connecting in series. So we are not going to consider potential voltage drop across this to this here now. We are going to measure, means the voltage will be almost very small. It is going to tell that one. But from one terminal to another terminal, here we are connecting at the point here now, terminal power line, and another one we are connecting to the earth here now. With reference to the earth, we are going to measure the voltage, means it is going to give high here now. So whatever the line voltage is there, full line voltage we are going to appear across the potential transformer. But here the series connected here now, so very less voltage it is going to exist over there. A small voltage exists across its terminals as connected in series, but full line voltage appears across its terminal for the potential transformer here now. And the winding carries full line current here. Now this winding is there, it is going to carry full line current. How much line current is there? Same current it is going to carry, but this winding is impressed with full line voltage here. Now this winding is, it is going to carry full line voltage, it is going to carry. It is not going to carry current here now. Okay. And the primary current and excitation varies over a wide range here now. It is whatever this primary current is there, it is going to vary, for the excitation wide range variation is there here. Now the line voltage is almost constant, hence exciting current and flux density varies over a limited range here now. It can vary anywhere, any out of range also, but it will limited, some surrounding plus or minus 5, 10 like that, 1%, 2%, it is going to vary for the potential transformers. The primary current here now, here the primary and secondary, there is no, here the current is flowing like this only, and the secondary current is flowing like this only. So primary current is independent of the secondary circuit conditions. Whatever you are going to connect here or there or not, it is not related to primary current here now, because we are not applying any load here. So for that reason, the primary current is also, it is connected in series, so it is independent of secondary circuits. It is not related to anything here now. But the potential transformer, what will happen? The primary current is dependent on secondary. It acts as open. Suppose I have added the load, means I have added, means what will happen? Roll number 5, Pallavi. Okay.
Hello, sir.
Okay, no problem.
Sorry.
Okay. So The primary current is depends on the secondary circuit condition here. Here, if this secondary condition is underload or overloaded, then the primary current will also vary over there. So this primary current is depends on secondary, but for the CT current transformer, primary current is independent of secondaries over there. It is not at all dependent over here, and needs only one bushing as the two ends of the primary windings are brought out through the same insulator. Hence, there is a saving in the cost here. No. So insulators means actually that is bushings means it is a insulators. I think पोल में आप देखो होगा ट्रांसफार्मर के ऊपर चॉकलेट कलर के एक अपर साइड रहते एक कप जैसा. यस, like a cup you have observed in the pole side, electrical pole को observe करो आप, नहीं तो TC रहते हैं ना एक round box में tank, in the over of that three terminals there will be like a cup like chocolate color is there, that is called bushing. So we are going to call that one. For the CT it is required only one side bushing is required. For the PT both side it is necessary. For that reason two bushings are required for the potential transformer, one bushing is required for the current transformer here. So we have already discussed about the some what is that one, potential transformer and current transformer equations. Just actually we have to, problem will not come in this one, but I have added one problem here now that is related to the current transformer and simple triangle based values we are going to consider here. Now this is a problem actually. The solution also it is going to display here. Solution it should not display. For that reason what we have to do, this is one term. अभी स्क्रीनशॉट ले लो किसी को चाहिए तो, बाद में ये विजिबल नहीं होते. Now is visible? Solution is visible or not?
No, sir.
No. Okay. So a current transformer has a single turn primary and winding here. No. Current transformer है एक, उसको primary is single turn, only one turn is there, and is 200 secondary turns are there. Secondary turns are 200 secondary turns are there. Okay. So 200 turns secondary windings. First point. The secondary supplies a current of 5 ampere. Secondary winding is there, it is going to supply of 5 ampere to a non-inductive burden of 1 ohm resistance here. Non-inductive burden is nothing but Z equal to R equal to 1 ohm here. Z equal to R equal to 1 ohm. So the requisite flux is set up in the core here. Whatever the requisite flux is there, it is going to set up in the core by an MMF, magnetic motive force of 80 ampere. Is nothing but whatever the magnetizing current is there. What is the unit of this one? It is 80 ampere they are given here now. Core by an MMF it is 80 ampere and the frequency is 50 hertz and the net cross section of the core is 1000 millimeters square here now. Calculate the ratio and pulse angle of the phase angle of the transformer here now. What we have to calculate? We have to ratio, that is called IP by IS, we have to calculate here. So to calculate IP by IS, they have given formula for the IS. Is they have given IS value? Yes. IS is given or not? First, what we have to write? We have to write the given data. You have to write there. A primary current transformer has a single turn primary here now. So NP equal to 1 number of turns 1. NS equal to how much it is? 200s are there. NS equal to 200. So we know that one. What is the ratio? By using the ratio, we can tell that one NP by NS, na? NP by NS equal to So NP equal to 1 means 1 by 200. 1 by 200. We can write that one here now. So N equal to 200. We can use that one. That is not necessary here. So I'll erase here. Okay. That ratio we can consider as 200 only. We can consider here now. The N is 200. Secondary NS it is 200. So next, the secondary supplies a current of 5 ampere. Secondary supplies means which current it is? Primary or secondary?
Secondary.
Huh? Which one? Secondary supply means it is secondary current only, na? 5 ampere is secondary current here now. So a non-inductive burden here now. Non-inductive burden is nothing but R equal to Z equal to 1 ohm here now. R equal to Z equal to 1 ohm. We can write here. Where it is going to use, that is called magnetomotive MMF. We are going to doing that one here now. So IM they are going to give here now. It is in the ampere, it is there, but for R we have to calculate here now. The magnetizing current equal to whatever this MMF is there, MMF per ampere or per ohm here now. I equal to V by R, na? So R is nothing but that R equal to Z we have to use here. What is this MMF is there? An MMF of 80 divided by 1. How much it is? 80 ampere only?
Yes.
So the magnetizing current is 80 ampere. Magnetizing current is 80 ampere. From the phasor diagram, we know that IP square equal to, we can write that NIS actually, NIS we have used here. NIS square plus IM square here. Plus IM square. Okay. So NIS for the CT, the ratio is NS by N here now. N equal to NS by NP here now. Secondary to the primary we are going to use here now. So we can write this one as 200. Yes or no? We can write this one, the reflection, we can write that one. Reflected current also we can call that one here. Reflected current is nothing but that is called N into whatever this IS here now. N into IS. So this N is 200 and IS reflected current, that is called here whatever this one is there. NIS equal to how much it is? 200 into 5. How much? A simple calculation.
1000.
Huh?
1000.
1000 is there. So 1000 ampere we are going to call this one here now. 1000 square and 80 square this one here now. Here IM is 80,000 square and IP equal to square root of, we can write like this, IP equal to the square, I will remove this one, I will use square root here, and 1000 square 1000 square plus 80 square we can use here now, equal to how much? You tell the answer. 1000 square plus 80 square and its square root. How much it is? Yes. I told while studying this subject, you should have to sit with calculator. How much it is? I have substituted 1000 square plus 80 square, answer square root. Square root of that answer equal to how much it is?
128.06.
128. No, wrong then. Square root of bracket 1000 square plus 80 square bracket close. No, Wrong hai. I am also having the calculator here. All of you, how you have the scientific calculator? Scientific calculator है क्या?
Yes,
नहीं
sir.
है, नहीं है, ठीक है. 1000 को स्क्वायर करो कितना हो गया देखो. 10 लाख. ये स्क्वायर रूट ऐसे ही रखो इसको, ठीक है?
Sir, 1003.19.
ओके ओके करेक्ट. सो हियर 10 लाख हो गए ये. 10 लाख. नेक्स्ट प्लस 80 स्क्वायर कितना हो गए?
6,400.
6,400 here no. 6,400. 10 लाख 6,400. इसको स्क्वायर रूट कर दो. 10 100 6,400. It is nothing but इसको आंसर करो इक्वल टू स्क्वायर रूट ऑफ दिस वन. It is going to give the answer is 1,000.
1,003.19.
1,003.19 is there. I will use that is called 1,003.2. I will use here. That is called primary current here. 1,003.2 is primary current. Okay. Next, what is the transformation ratio formula? The transformation ratio R equal to, what is the formula? I by I. Which I it is? Primary to secondary or secondary to the primary?
IP by IS.
IP by IS here. No, IP by IS here. What is the value of IP? Just now we have calculated here. No, that is called 1,003.2 divided by, what is the IS value?
5.
5. What is the answer? 1,003.5 3.2 divided by 5. It is nothing but, मैंने एक्सप्लेन करो क्या कैलकुलेशन करो. आप लोग कैलकुलेशन करना है एक्चुअली. Hmm.
200.64.
200.64 is the transformation ratio. Transformation ratio. So next we have to, what is the question here? No, calculate the ratio here. No, the ratio we have calculated here. It is over now. Next, what we have to do? We have to calculate tan theta. Tan theta equal to IM. Based on these two only, these two currents only we have to calculate. IM divided by magnetizing current divided by reflected secondary current here. That is called I naught actually. IM divided by N into IS. N into IS. How much IM is there? IM is 80 divided by 1,000. How much it is? 80 divided by 1,000. Calculate.
0.08.
0.08.
Whatever it is. 0.08.
08.
It is tan theta. Then tan theta equal to, sorry, theta equal to, we can write tan inverse of 0.08.
Yes, sir.
Yes. Calculate karo tan inverse of 0.08.
4.57.
Just a minute. Tan inverse of 0.08. कितना है?
4.57.
4.57. Okay, no problem. 4.5 or 4. Full complete use किया तो 4.3 something it is going to get. So 4.5 degree here. So like this, simple problems will come if the online exam is there, offline exam is there. But anyhow, you are going to study in the online. The exam will be online only. So maybe some disturbance is there. आवाज आ रहा है क्या पीछे?
Yes, sir.
Okay, so it completes the fourth unit. It has completed now. The fourth unit has completed now. So based on that, I have already given some assignments also for you people. So the assignment questions. Okay, so it completes the fourth unit now. So before starting going to the fifth unit, some assignment questions you have to solve. These 9 questions are there extra. Also, you can take that one. So the first one, assignment number 4, 4 or 3. Actually, inductance bridge आ गए क्या?
4.
4 हो गए क्या? 1 minute. Fourth means what do you have to get? CTPT you have to get, na? I don't know.
Yes,
Just a minute. कहाँ ऐड किया मैंने फिर? ये पीछे हो गया. नहीं है. So this one only double bridge. ये already third unit में हो गए ना ये?
Yes, sir.
Is busy and all the things. So just a minute. I will stop sharing here only and I will open the assignment booklet. I will tell that one based on that. So are you writing the assignments or not? How you are submitting the lab manuals, like that only I am going to collect the assignments. I will not give the link now, but later when the 6th unit will complete, on that time immediately I will tell you to upload the assignments. Who will submit the assignments, they will get the marks. Otherwise the other people will get 0 marks. Remember that one. For the assignment, it is going to cover in the term work. Term work, we are going to cover this assignment also. Some error is coming. Okay. So I will go to the 4th unit. That is potentiometer and bridges already over. Only 2nd unit and 3rd unit was very bigger actually. 4th unit is easy only. Okay, transducers and instrument. So the first question you take down, give the classification of transducer. With need sketch, explain the strain gauge. Strain gauge is not there, no? It is not there for you peoples. Give the selection criteria for the transducers. So write some selection criteria, how we are going to select based on that what, its temperature, heat, displacement area, and all the things. Explain the current transformer with neat diagram. Explain the pressure transducers. This one, you take that one, pressure transducer also. Describe turns compensation in case of current transformer. If you explain this current transformer complete, then no need to take about this turns compensation and all things. This one also not necessary. I will mark here only, pen and paper. I will write this one you have to write down. It is not there. Give the selection criteria. Current transformer with need diagram. Pressure transducers. This one also no need to write. You will do that one. compensation techniques to reduce the ratio in the transformer, typical phasor diagram of potential transformer, a difference between CT and PT. Screen is visible or not?
Yes, sir.
Assignment questions visible है ना?
Yes, sir.
Yes.
अरे आप पर किया तो गए ना वो, देखोगे? First one is give the classifications of transducers. Second one is give the selection criteria for the transducers, and draw. Sorry, one more. Explain current transformer with need diagrams. Fourth one. Draw typical phasor diagram of potential transformer and derive expression for actual transformation ratio. Fifth one, difference between CT and PT. लिख रहे क्या? स्क्रीनशॉट ले रहे?
क्वेश्चन नंबर लिख रहे हैं.
सिर्फ क्वेश्चन नंबर लिख रहे क्या?
Yes, sir.
ठीक है. Can I go for next?
Yes, sir.
Okay. Some problems they have given. No need to take that one. It's applications of investment. This one also you write down. Write the advantages and application of instrument transformer. 12 number. Write the advantages and application of instrument transformer. Good. Next one, this one, 16th one. Define the following terms as applied instrument: transformation ratio, nominal ratio, turns ratio, burden of transformers. But already in the first class of this, before starting that one only I have explained this one. The theory part only I am giving. And in this one, actually transducer part we have not mentioned. No? Next question you add, we'll add some questions here now. With need diagram, explain. लिखो अभी ये क्वेश्चंस लिखो ये. With the neat diagram, explain the construction and working of first one RTD, second one LVDT, and third one RVDT. ये तीनों लिख दो. These three are the important things we have to write. How many questions are there total? कितना questions हो गए? 8 questions ना?
RTDT, LVDT and
So you complete this assignment, it completes, I can declare that it completes the 4th unit is completed, and 5th unit tomorrow class I will start that one, and be ready for the chapter test. Maybe tomorrow I can conduct the chapter test for you peoples. Understood? Okay. One more very important thing I want to ask you peoples. If anyone have the first year subject, backlog subject है क्या किसी को? Actually, I just now I got the call from HOD. Just a minute, I will stop recording.